Welcome to Saitechinfo channel, my dear students. In today's session, we will discuss some of the basic aspects about the vector algebra. The quantities can generally be classified into scalar quantity and vector quantity. Scalar means it has no direction, it has only magnitude. Whereas vector is having both magnitude and direction. For instance, distance is a scalar quantity because when I say distance, it has no direction. But displacement is a vector quantity because from where to where we need to indicate the displacement. So the direction is involved. So vector, as I already mentioned, has both magnitude and direction. Let us talk about these speed and velocity. Speed is the distance divided by time. It means the distance traveled in a given time. That is called speed. We say several miles per hour or kilometers per hour. The car is traveling in this speed, 60 kilometers per hour, 100 kilometers per hour, like that. But when we mention the direction, that is velocity, it is represented as what? That is, in which direction it is going with a particular velocity. So velocity is a vector quantity and it is expressed in terms of SI units, that is meter per second, in what direction, that has to be mentioned compulsorily. So that makes the difference between speed and velocity. Therefore, speed is equal to distance divided by time, whereas velocity is equal to displacement divided by time. And, and hence, velocity is a vector quantity, whereas speed is a scalar quantity. Now, let us have this. Now I have represented a particular length with some direction. It means a displacement has occurred from this place to the other one, other point in an upward direction. And what about the second one? It has traveled, the mass, a point has traveled downward. So that is represented by the direction, that is arrow mark. So necessarily we need to say that is as a vector. For instance, let us say a car travels from A to B in this direction, that is A vector. So it can be represented as AB vector or A vector. So if it is AB vector, that is, it should be represented by this symbol arrow mark A to B. When you want to, that is, reverse the direction, you can reverse the arrow. So B to A. So you can put AB. Okay. So either way you can represent, that is, let me say A, B. In this direction it has gone. Now when it is reversed, we can put AB in this way. But by convention, we don't agree upon this one. So we go by, we can put minus AB, that represents what? The direction has changed. Is it not? So it is indicated in terms of plus minus. When I say minus AB vector, it is understood that the body has traveled from B to A. Otherwise, you can put BA also. Okay. So by convention, this arrow mark is represented as left to right only and not right to left. So even though it may be correct, but this is not by convention. So let us not let us ignore this one. Let us take this. So when we say like this, that is AB vector is opposite to minus AB vector. I hope now it is very easy for you to understand this. Is it not? Right. And if it is represented as, see, the onward direction is this one, then how to represent the reverse direction? You can put simply minus, so that that represents the reverse direction. You understand? Now, let us go ahead. Sir, it means we have two important points here. As I already mentioned, suppose if the car travels in this direction from A to B, now as I already told you, it is represented as A. So A is the initial point. Do you understand? Similarly, B is the terminal point. B is the terminal point. So when I put A vector means AB vector means A initial point to B terminal point. Do you understand? Now how to represent the magnitude here? You had to put the modulus. So when you represent by this, it indicates the magnitude of the vector, and this can be represented as AB modulus also. Otherwise, you can simply put A that represents the magnitude. Do you understand this? Right. Next. So, you should remember length cannot be negative, but the notation of this one means what? And that is why we have put modulus, is it not? So this negative notation represents the opposite direction. It has nothing to do with the magnitude, and that is why we put modulus and make it absolute so that you will get positive value. Okay, right. Now let us consider this x, y, z dimension. So x, y, z directions. This represents x-axis and y-axis, then z-axis. Now, origin is represented as 0, 0, 0. Okay, so it has not yet started. Let me say a vector, a body moves in this fashion, in this direction. So that is OA, that is represented as vector A. OB, vector B. OC, vector C. Okay, so in your textbook, normally they represent by bold letter like this. Okay, if it is a vector, they will represent by a bold letter, but they don't write, simply they ignore this one. That is, they don't put the what? The arrow mark. Okay, so if it is given in bold letter, it is understood that this is a vector. When they put f in bold letter, you have to take this is f vector, but you must write this as what? F vector. So remember this is the sign convention practiced in your textbook. So never get that is confused with that. So don't argue that it has not been given as arrow mark as a vector. Okay, so for their typographic convenience, they have put simply bold letter, but it should be noted only as arrow mark. You understand? Right. Next. And we were discussing about various vectors, A vector, B vector, C vector, etc. Okay, right. Now, let us consider a point in point P in space having the coordinates x, y, z. We do not know that is in which direction the body is moving. Assuming that if it is moving along x-axis, then we can say definitely it is along x-axis. So you can represent as x-axis. And along y-axis means you can represent as y-axis. Along z as you can represent by. So in this case, as a point in between they go. Okay, so they are called position vectors. It means that is it has originated from the origin. It has started. It has initiated from the origin. And that's why this OA vector, what is this OA vector? Which is nothing but A vector. What is OB vector? Which is nothing but B vector. What is OC vector? Which is nothing but C vector. Do you understand this? So these are all called when it is orthogonal, that is when it is started from O, that is origin, then it represents the position vector. Do you understand this? Right. Now, and we know by using the distance formula, what is OP? Let us consider any point. So like this P, OP. So that P is represented as X, Y, Z. Probably that is from x-axis, it may be that is in this way it has gone, so we can put -2. Y-axis means here around 4, and z-axis around 3. So likewise, that is we can fix the point here in terms of x, y, z. Okay. Now this OP, that is the OR vector. This OP, and when we want to, that is a, when you want to measure the magnitude of this OP vector, then you have to follow this formula, that is OP, because as I already mentioned, the magnitude of the vector is represented by what? Modulus of that particular vector. So OP vector, the modulus of OP vector is given by the whole square root of x squared plus y squared plus z squared. So about which we already discussed in our previous class, that is in 11th standard itself. And before that, in practice, that is, it can also be represented as A vector, B vector, C vector also. Okay. So the magnitude, whenever you calculate the magnitude, you can apply that distance formula, and you can sum the squares of the respective vector, so that you will be able to calculate what? That is OP vector magnitude. Do you understand this point? Right. Now let us consider this cube. Here O is the origin, and x along x-axis, along y-axis OY, along z-axis OZ. Do you understand? Now that is OA, that is represented as x, OB y, OC Z. Okay, then what about the point P under observation? It will be lying based on the xyz, so we can represent this as P of xyz. Now you must remember one important aspect, that is, let us consider this OAP, and you may find A is perpendicular. Do you agree with me? A is perpendicular. So OAP, you have to visualize this very carefully. And similarly, let us identify, that is OBP. OBP, where B is at right angle, that is 90 degree. Similarly, let us consider this, okay, O, then C, and then P. Okay, now C is at perpendicular line, okay, perpendicular angle. Do you understand? And as you know already, that is the longest side, or the side just opposite to the right angle, is hypotenuse. So you can find in all these cases, that is R acts as hypotenuse. Is it not? You just look at it. Let us say that, this will be very easy. OCP. In OCP, you have got the angle C 90 degree, and the opposite side is OP. Do you agree with me? That is R. Okay. So similarly, that is OAP and OBP. Okay. So in all these cases, R is the resultant, and that is the 90 degree. I mean, that is the hypotenuse of all these triangles. Okay. Right. And so I have given here separately also OAP. Do you understand? OA and then P. So it is given here. This is 90. Means OP is hypotenuse, is it not? And when you consider this as angle, then definitely opposite side is OAP. Adjacent side is OA. Is it not? Right. So just to visualize it and draw this diagram carefully.